the most important topic of today's scenarios, that is introduction to the CAD. Myself, K. SUDHAKAR, Assistant Professor, Department of Mechanical and Automation Engineering, PSN College of Engineering Technology and TIRUNELVELI. So, first of all, what is meant by CAD? So, CAD is a computer-aided design. Whatever the design assisted by using the computer softwares like design softwares, that is called CAD. That is will be computer aided design. The definition of the computer CAD is it is a technology concerned with the use of computer system to assist in creation, modification, analysis and optimization of design. First one is creation is what are we creating, lines or points or layout of the diagrams, that one. Next of all, after the creation, if there is any errors or any modification, any changes you have to do, means you have to do the modification. After the finalizing the modification, we are going for the analysis. In analysis, we are applying the load or whatever tests you want to analyze. We can analyze like load testing, like frequency, like heat treatment, whatever flow analysis, everything we can do that. After analyzing, we are finding the optimization of design. Optimization of design is nothing but what are the correct design for a particular product, because each product have different parameters, different functions. For testing the some softwares analyze particular parameters only, like one software will analyze as 2D and 3D modeling only. In SolidWorks we can use as a 2D and then we cannot analyze that. But in ANSYS, AutoCAD or we can analyze the job. That is finding the optimization design. Okay, here you see the geometric model, first one, and then design and analysis, and design and optimization, and drafting and documentation. So, first one is geometric model. Geometric model is the actual layout of the product, material, everything. And then after the geometric model we analyze that, we have to identify the design, how we are going to create the model in particular software. So we have to use x-axis, y-axis, in x-axis whatever the coordinates will come, in y-axis what are the steps, first steps to draw the line, which one is possible. You have to use a step-by-step procedure of the design, how we are going to design. So next, after the designing, we are analyzing the design, whether the parameters are given correctly or anything we can analyze. After analyzing, in analysis there will be a testing also will be done. And then in design optimization, we are after the confirming the design, after confirming the design optimization, and we are going for the final product of the material. In the drafting and documentations of these are the CAD. So basically, by assisting the design, assisting using the computer knowledge is called a CAD. That is called as computer-aided designing. So next we are going to see what are the different terminology related to CAD. So in CAD there is a terminology like a CAM, right? It is a computer-aided manufacturing and a computer-aided engineering. So first of all, first we know that CAD is a computer-aided design. Now we are going to see the computer-aided manufacturing. So it is a technology concerned with the use of computers systems to plan, manage, inspect and control manufacturing operations directly or indirectly. So in CAD we are creating the model and we are analyzing the product and we are going for the documentation, drafting. But in CAM, that is a computer-aided manufacturing. After the design is confirmed, we have to move to the manufacturing unit. Before manufacturing, we have to schedule the job. How many jobs should be middle? Which one is the first one? Which one is the second one? Which one is the third one? We have to plan the manufacturing process, because we can not fully made one product in one step itself. We have to give step by step only. We have to manufacturing process. So you can see the flow chart of the CAM. So first one is a geometric model. That is the final product of the manufacturing model. And then we are going for the process planning. What are the process in, if we take engine means we have to manufacturing part by part only. So first part we are what we are going to do. First part we are going to create the camshaft. Second part you are going to piston head, and then steel molding. Like that we have to give the process planning. After the process planning, we have to give the, for single process also we have to give the programming. What are the program, because it is not a manual program, it is a automatic program, automatic manufacturing unit. So in automatic manufacturing we have a NC program, that is a numerical coding, like G code and N code we have, geometric model coding and metric model coding. That is in which we have to give the for if we take the piston head means we have to give how the piston head should be manufactured. That is called coding. We have to give the NC part coding. After the coding, we are given the machining process will start. So after the machining process will drafting and documentation, last finally the output will be get to inspection product. So after the inspection, in inspection if there is any problem occur means we have to do the redo the we have to recheck the part program. That is we have to change the numerical coding. We have to change the coding, and then we have to again give the manufacturing process. So next one is and then after the inspection is we are going for the sales packaging, and we are going for the sales. So what is the computer engineering? So it is a technology concerned with the use of computer system to analyze the CAD geometry, allowing a designer to simulate and study how the product will behave. Now in CAD we are only the designing. In CAM we are manufacturing. In computer engineering we are simulating the manufactured product, because after the manufacturing we have to test the product. So like a load test or chemical treatment or a heat treatment, we have to analyze that. So for that we can use the computer aided engineering. So it will simulate the product, like you can see the how the material in that if you see the piston head, there will be a blue mark and a green mark and a yellow mark and a red mark also will be there, light red, and this is the color of coding of impact, because the blue coding is mild damage and green is no problem and yellow is medium damage, and then red color is a critical condition and anything. These are the basic colors. So by this we can understand how the materials will behave due to load. This is the CAE. So we now what is it? We see the CAD, CAM and CAE. Okay. Next one is CAD tools. What are the CAD tools? There is computer graphics concepts, design tools and geometric modeling. So there is the computer graphics concept and then design tools. What are the design tools we are going to use, and what is the geometric modeling we are using? So computer graphics is nothing but the softwares. What are the softwares we are going to use? So design tools means what are the design, what are the heat process, what are the testing process we are going to use. Okay. So these are the difference between CAD drafting and CAD redesign. So in this is done after the analysis performed on geometric modeling. So in CAD we are using the modeling and we are going to analyze. But in CAD material design and modeling is we can perform the analysis. Okay, after done before that. So these are the basic things. We can move on to the next one. That is the components of CAD system. What are the components are in the CAD system? So in CAD system there will be two components, that is the hardware and the software. Okay, in hardware we have the computing machines, data storage device and communication device and user input device and user output device. Okay, you already know the what are the hardwares. Hardwares is the what are the devices we are having as a hand in. So what is a competitive machining is computer. What are in design, which computer we are going to use, what are the types of in that, what are the data storage device, 1 TB or 2 TB or 3 TB or that. And then what is the communication, what are the communication device we have. Okay, and then use the input device like keyboard, mouse, like use the output device like material output, everything. Okay, what are the softwares? In software there is a solid modeling, assembly modeling, motion simulation, final assembly. In software, in that we can like ANSYS software. So in ANSYS software we can see the solid modeling. In build of the ANSYS software there will be a solid modeling. We can model, we can test the solid modeling, and we can also assemble by using the components. We can, because we can create 10 parts in one single design, and then we can arrange it in one piece. That is called the assembly modeling. And also we can use the simulation process. Most simulation, that is a flow analysis. We can pass the heat from one side to another side, or in hollow shape product we can pass the water, like water, this amount of water, 100 pieces of water is passing through from one pipe, from 2-inch pipes to 3-inch pipes. We can simulate that. Finally, we can use the finite element analysis. FEA is the by each element, because in drawing the elements are represented by the nodes. There will be each node, there is a 0 to, there will be n infinite number of nodes will be appear. We can go 0 to 1 means there will be 10 nodes will be appear. So from nodes we can give the particular node, we can analyze the, we can give the load, or we can give the frequency, anything we can do that. So these are the components of CAD system. Next one is hardware components. Like input device, already I told that the graphics device is composed of display, processing units, and display device. The input device are mouse, space bars, data tablet with plug and keyboard, and output device is plotter, color laser printers, laser displays. That is the external part of the computer. What are the device output we are displaying? Okay, you already know. In software we are using the CAD software. The CAD software is allow the designer to create and manipulate the shape interactively and store it. So in CAD software, the designer, we can, for designer will be create the component and it can manipulate the shape. Okay, we can manipulate means we can change the shapes. In CAM, we can software plans and manage the plans and manage and control the operations. Okay, so these are the in CAE software analyze the design geometry and allowing the designer to study product behaviors. Okay, and then next one is CAD software. So the CAD software can be divided based upon technology used, like a 2D drawing, 3D drawing, sculpture surface, and then engineering analysis. First, you already know the what is the 2D. You have to know the 2D. 2D drawing is the layout of the components, because we can see the line diagrams. That is called a 2D diagram. Okay, in 3D diagram we can see the solid diagram. We can see the solid diagram of the this one is 3D diagram. So in 2D diagram we can use the, first of all you see the 2D diagram, 2D drawing, and first one is a mechanical part drawing, and second one is a printed circuit board design and layout, and facilities layout and category. Already I told that that is a layout of a layout or line diagramming of the material or component. So that was they are saying. Okay, in basic 3D drawing is such as wireframe modeling. So wireframe is, there will be the 3D structure will be like a wireframe. We can change it to surfaces. Okay, like a 3D models. The sculpture surface are also surface modeling. That is sculpture we can surface the fully preloaded surface structures. In that we can cover the surface. We can go through the upcoming that I will tell that. So first is the design process. So most first one is the design process. The design is the act of revision and an original solution to a problem by combination of principles, resources, and products and designs. Okay. It is what is the saying means, the design is the act or division of original solution to a problem by combination of principles and resources and product and design. So by using the principles how we have to design the product as per the norms, what are the resources we are taking, what are the sample products or pre-loaded or reference model we are taking. From that only we have to design, we are going to design, because whatever the new product also, there will be always the structural designs will be there. We have to compare or we have to analyze the previous designs, and then also we can give a actual solutions to that problems. Okay. Next one, it is an iterative process which checks the suitability of the design again and again. So we can by checking, by analyzing the principles or by analyzing the designs, we can continuously we can check again and again. Whatever, how many times we can analyze the designs. There is no there is a limit, there is a restriction, there is no, because we can check the designs a number of times. Okay. Next, the design progress is a step-by-step manner from some statement of need through identification of problem, search of solution, development of the chosen solution, to the manufacture, test and use. Because in design process there will be a step-by-step process like a planning, analyzing, what is the first, identifying the problem, and then we what are the for rectifying the problem, and then we are collecting the data, and then we are designing the temporary designs, and we are analyzing that. If analysis is okay, means we are converting the design, confirming the designs, and we will move on to the next manufacturing units. These are the basic design process. So let us see the flow chart of that. The first one is the recognition of need. Okay, for what purpose you are designing the process material means, for what purpose we have to know the what purpose we are designing the product, because we cannot simply create one product easily, because we are going to use the product in day-to-day life or day-to-day or in companies or household things, anything we are going to, because it is based upon one scenarios or one particular job, it when the process and the product will be used. So we have to collect the what are the needs of the design, why we are creating the designs. Okay, well, you have to prevent the needs. Then we have to, if I find the needs means there will be a problem, any problems are there. We have to find what are the problems in the previous designs, because there will be, for every need there will be a designs or previous design, previous products will be there. In that product, what are the drawbacks we have to identify. So from the drawbacks, we are rectifying the problem, and we are going to create the altered design or new design. Okay, that is the definition of problem. What we have to define the problem. For the problem, we have to synthesize. Synthesize means for rectifying the problem, we have to collect the data from the designs, and we have to give the extra new ideas, or we have to collect the what are the designs should be that, what we can use a new alteration techniques we are going to use. We have to synthesize that. After the synthesis, after collecting the data, after collecting the design procedure, we are going to design the process. So, and then we are after the designing, once we are designing for a particular problem, we are designing the one product. So after the designing, we have to analyze the design, whether the design is okay or not. Okay, so for that we are going to analyzing the design by using softwares like testings, like a load test, chemical treatment, what are the testings. So for how the material will behave. So we are taking the different tests, different scenario, different results, and after the analyzing the product, we are evaluating. Evaluating means what are the readings are saying, how much differ from the old one to other one, whether it is okay or not. The design is that. If the design is not by any evaluation, the designing parameters are not okay, means we have to change the design. We have to move upward. We have to move upward means what are the design process should be changed. After the design process, again we are synthesis and again we are analyzing. Once the design is improved means we can only move to the next position. If it is no means we have to continuously change the designs. Okay, that's what they are saying. After the evaluation, if no means you have to change the design. If the design can be improved means the design is can be improved. After the 10 or 100 tests also, 100 design changes also, there will be no improvement means the design is failure. So we have to go for the new design only. Okay. So if it is a yes means the evaluation is okay means we move on to the manufacturing. We can move the design to the manufacturing unit. Okay. These are the geometric modeling. First one, we see the geometric modeling, geometric tools, and what are the geometric modeling, design tools, and computer graphics concepts. So now then first we are going to see the geometric modeling. So this modeling is a set of techniques concerned mainly with the developing efficient representation of geometric aspects of a design. Because in geometric modeling there will be some techniques. So okay, from the techniques we are developing the designing. By using the techniques we are developing if you take your own data from on that. In that we are developing one product from a length to increasing the length or decreasing the length, everything we can alter the designs and we are representing it to that is called geometric modeling. The modeling refers to set of techniques concerned mainly with the developing efficient representation of geometric aspects of design. Therefore, the geometric modeling is fundamental part of all CAD works, because in geometric modeling only we are going to draw the design. So like as a basic design process, here also there will be a first one is need of design. Okay, next one is what are the specifications, what are the finding the problem, what are the specification you are going to include that, and then we are going for the conceptual design. So conceptual design is that it is not as a final design, it is a one concept design, like it is a primary design. This is not as a final design, it is a primary design. In that primary design we can continuously alter the design. Okay, so that is a conceptual design. After the conceptual design there will be concept design check. If it is a safe means we can move to the preliminary design. If it is not safe means we have to analyze, we have to rechange the conceptual design. If the design is okay means we can move to the preliminary design. Preliminary design is a medium of the design. That is, this design is okay. The conceptual design is okay, but there will be analysis will be there, like testings. After the testing also, the design process will be failure. Okay, the design will not be safe, because in conceptual design we are without testing we are checking the design. This design will be worked on as the assumption we are setting the design. If on that design we have to approve. Okay, because first you have to approve that we go to the preliminary design. In preliminary design there will be a engineering analysis on geometric modeling. So we are analyzing like a load test or anything we are applying that. In the test, the test will be okay means it will go to the detailed design. The detailed design is nothing but a manufacturing design. That is the final design of the product we are going to manufacture. Okay, that is the detailed design. After the detailed design, it will move on to the prototype testing, because every product there will be a prototype. The prototype is the actual die of the material what you are going to manufacture. From the die only we are going to manufacture each and every part of the machinery. So there will be a prototype testing. If prototype testing is safe means we are going for the final production drawing. So the final product if the shape means the detailed design will be move on to the final production drawings. Okay, so these are the applications of the geometric modeling. Is a mass property calculations, mechanism analysis, final element modeling, and then NC programming. So these are the geometric modeling is the basic of many applications. Mass property calculations, we can give the we can analyze the mass quantity, we can analyze the 2, 3 more 5 quantity, we can calculate mass property. And mechanics analysis are in software there is a lot of mechanic process analysis are there, and the final modeling also we can do that. And then in numerical coding also, because in previous years we have a manual thing, now we are having the automatic CNC machines at the computation numerical codings. By using ANC programming, we can also design the manufacture the product. So the requirements of geometric modeling include the completeness of part presentations. Okay, this modeling method should be easy to use by the designers. So the completion of part presentation means if you are taking the engine means there will be 100 number of parts will be there. So we can in geometric modeling we can fully complete the each and every part of the what we are going to present in. Okay, the modeling should be easy to use by designer, because we are in geometric modeling we are going to 2D or 3D diagram only. So that we can easily for the designers they can easily understand the what designs are being made. Okay, and then next one is rendering capabilities. That is, which means how fast the entities can be accessed and displayed by the computer. So rendering is what is the displaying, because by applying the testing once we are applying thermal test on the one square shaped cube means on one surface, one side of surface means how quickly the results will be displayed. That is called geometry, because the components have a low absorbs the low graphics only. So that the entities, how fast the entities will be. Entity means how the graphics will be represented by using a computer. Okay. Then geometric modeling approach of types are there. First one is wireframe model, second one is surface modeling, and third one is solid modeling. So let us see the wireframe modeling. So wireframe modeling is a visual presentation of 3D or physical object used in 3D computer graphics. Okay, that is a visual representation means what we are seeing through display. So this is the display. What are the displays showing? How the model is there? Like in x-axis how is there, in y-axis how is there, in z-axis how is there. Okay, so that is called a visual representation of 3D or physical object used in the 3D computer graphics. Okay, so usually it is like some points, curves. Okay, by connecting them using the points of coordinates or vertices. Okay, so you can see the cube diagram, you can see the square circle diagram, you can see the pentagon, hexagon. So okay, these are the wireframe model. So it looks like we can see we can rotate from y-axis or z-axis, we can see the whole diagram how it's formed or like that. Okay. So it is created by specifying each edge of the physical object where two mathematically continuous smooth surface meet, or by connecting an object consistent vertices using straight line or curves. Because it will in wireframe model we can create the specific edges of the physical object, because each and from corners because in CAD software there will be a node points will be there. There will be a lot number of nodes will be assigned, like in the graphical view there is a 0 to 0, 1, 2, 3 we can like in same that there will be a node 1, node 2, node 3, node 4, node 6. By using the nodes we can easily specify or easily we can identify or easily we can create the object by using points, lines, circle, all basic components. Okay, that is called, for example, they are showing the AutoCAD or SUDHAKAR. Okay, these are the wireframe model. So next one is surface modeling. So surface modeling is more sophisticated than the wire modeling. Then it defines not only the edges of the 3D object but also its surface. So in surface modeling, the objects are defined by the bounding phases. Surface are created by connecting the lines. Because in wireframe, you can only see the 3D diagram of wireframes only, because outer layers of the 3Ds. We already know what is in 3D. 3D is a solid part of that, but in 3D also, in that wireframe is, we are representing the 3D model as a wireframe. Okay, in that we can't choose the surfaces, but in surface modeling is an actual 3D object. Because we can say take the cube means the actual 3D cube. Okay, that is called surface modeling. In case wireframe of the cube means that is wireframe model. So in surface modeling, by connecting the all edges, all surfaces, we can create the 3D object. Okay. And the second point is what is saying, the model of the type is used for representing only the surface like sheet metal covers, cardboard exteriors, etc. Okay, that is called a sheet metal covers, like open surface of the cardboard exterior. Cardboard exterior means the outer layers of the cars. Okay, that is called as the surface modeling. So next we are going to see the surface entities. What are the surface entities of the similar to wireframe, the existing CAD/CAM system provides designers with both analytic and synthetic surface entities. So, what are what is analytic, what is synthetic? So, analytic entities includes like a plane surface, ruled surface, surface of revolution, and a tabulated system. So, analytic includes means the plane surface. Plane surface means the normal surface of the object, and the ruled surface is the graphical view of the surface. Because in that there will be a graphical view, graphical structures will be available in the ruled surface. And surface of revolution means we can rotate the surface. Like we can by using the z axis, we can rotate the surface of the 3D object. And the tabulated cylinder, it means we can easily tabulate how much is required. We can easily tabulate that. That is called analyticals. In synthetic, there is a bicubic, hemispine lines, B-spine. The spine line is the increasing, decreasing line of that. That is not as a straight line. So if we have a 0 point in y-axis, means the next point of y-axis is 1, and next to third point is y is 0, and then we have a y is 1. That means that is like a frequency wavelength is called as a B-spine surface. The spine line is also called as a frequency wavelength. Because the wavelength is not in a straight line, the wavelength will be when any body contact means the wavelength will occur like up and downs of the lines. That is called the B-spline lines. Okay, and the rectangular and the triangular Bezier patches. Okay, and the rectangular diagonal cone patches are like that is called as a synthetic entities. So we can say first one is the plane surface. The plane surface is the simplest surface. It requires 3 non-coincident points to define the infinite plane. Because you can see the diagram that is called as a simplest surface. So that is a normal surface. Okay. So if you see the ruled surface, in ruled surface, this is a linear surface. It interpolates linearly between two boundary curves that define the surface. So you can see the boundary lines of the surface. In that there will be a segment, several segments are arranged. Each segment is covered as the edges will be covered. So by using this rail, for example of the rails, this is called as a ruled surface. Because the entities ideal to the represent surface that do not have any twists or kinks. Because there is no bending, it is a straight line of the boundary curves. Okay. Now already follow the surface of revolution is the revolution type. Using the z axis, we can rotate the object, rotate the model to see how the design is made. So that's what they are saying. This is an axisymmetric surface that can model asymmetric objects. It is generated by rotating the planar wireframe entity in space about the axis of symmetry at a certain angle. In certain angle, if you want to rotate the model in 40 degree or 30 degree or 180 degree or 360 degree, we can, based upon our angle, certain angle, we can rotate the surface. So next one is the tabulated cylinder. So we are going to establish this surface generated by translating the planar curve with a certain distance along with the specified direction. So axis of the cylinder. So cylinder is by if the surface has a planar surface, by using the planar surface, we can bend or twist or turn the planar surface for a required surface. That is called tabulated cylinder. So there will be a plane surface. For our convenience, how we are creating as a hollow shape or sphere shape or circle shape or rectangle shape, by using the tabulated we can change that. So this is a BC surface. This is surface approximately given input data. It is different from the previous surface in that it is a synthetic surface. Similarly to the BC curve, it does not pass through all given data points. It generally surface the permits, twist and tingles. The BC allows only global control of the surface. Because in basis surface it will control the global control, because if you simply take the car means the surface will be created what the car design is there, because what are the outlays of that. If there is any bend, any twist, any holes are available also, the basis surface will create the surface from the, because it will directly apply to the surface of that. In that click we can see the what are the downs and ups and downs will be, we can easily understand that. Okay, and next one is a baseline surface. This is surface that can approximate or interpret given input data. It is a synthetic surface. It is generally surface like a BC surface, but it is an advantage of permitting local control of the surface. So let us going to see the solid modeling. So solid modeling is solid models gives the designers a complete description of constraints, shapes, surface, volume and density. Because in solid modeling there will be a certain shapes will be there. What are the shapes we are going to create, that the surface, that there will be a surface will be there. For that there will be a volume. That will be, if you take a cylinder, there will be a density will be there. So that is called solid models. So we can say the three-dimensional model that includes complete internal and external details on the design. Because in solid model we can see the complete internal and external details. In internal means what are the inside of the model, how to behave, and in outside of the layer how it will have to represent. Either we can easily identify get the details from inside and outer side. Okay. So solid modeling software like a SolidWorks, Inventor, and like the AutoCAD, everything is there. These are the CAD system architecture. Okay, so the CAD system comprises the following. First one is hardware, second one is software, third one is data, fourth one is human knowledge. Okay, based upon these four, we are going to see the CAD system architecture is there. So first one is hardware. You already know the hardware and associated peripheral equipment. What are the equipment we are going to use for design process. And then software. Software is what are the computer programs running on the hardwares. Because like analysis softwares, what are the data means what are the data system created and manipulated by the hardware. What are the data system we are uploading into the system. What we are deleting, what we are adding, what are any single functions that it will be stored in the data in the hardware. And what is the human knowledge and what are our knowledge, what are we going to design the process and activities. Okay, so these are the basic data. First we are going to see the model definitions. So and then second one is the manipulation, and third one is the picture generation, and fourth one is utilities, and fifth one database management, and we are going to output applications. So first one is the model definition. First one is what are the model we are going to define, and then we are manipulating the model. Manipulating means we are applying a test or anything with doing that, and then picture generation means the display of the model, how the model will be displayed. So and then we use the utilities. What are the utilities we have to use? What are the input data? How the output should become. That we have to define that, because we are feeding the input, but we are also required what are the output should become. What are the output should we have to take. In certain there will be a lot of analysis output is there. That is the input output from the user data we are giving in the utilities. After utilities, the working in the utilities there will be database, compound models, drawings, standards, library data, and working data and geometry, associated data and manufacturing. So in utilities there will be database, what we are giving the input, and the compound models also be given that. In utilities there will be drawings also, model drawings also will be there, and then what are the standards, principles will be there will be applicable in the softwares, and then library data, that is the previous data, comparison data, and then it is a working data will be also available, and then geometry and associated data, and then manufacturing. So these are the parts will be available in the utilities, because the utilities is the final data output of the after the utilities what are the connections, what are the testings, what are the things we have done, that will be stored in the database management. Okay, from the database management we take the data to the what are the application we are going to use in CNC machine or 3D printing, what are the machine we can directly apply to that design. So these are the benefits of CAD. First one is the automation of routine design talks to increase the productivity of designers and engineers. Okay, so CAD means by using the routine design, if automation in routine design means we can increase the productivity of design, because if one design is okay means we can easily go to the manufacturing machine, we can improve the productivity. If there is any error occurring means that will be degraded to the companies. So second one is make the designers to concentrate more on creativity. So designers to concentrate more on creativity. So while we are analyzing the CAD, or what are the products we created means, by using the model repeatedly, we are using different type of model means the creativity idea of the designers will improve. Okay, next one is due to 3D visualization of the model, there is an increase of design conscious capacity and hence the quality of design. By using the, because in 2D we can't now easily analyze it, but visualizing 3D visualization like in graphical view, like how much defects by applying the effect, how much defects displaying through the software means we can easily understand the what are the major damage occurred while operating the particular testing. We can easily understand, and we can also improve the quality of the designs. Okay, next we are is the creating prototypes using digital manufacturing. So by using 3D printing, we can easily create the prototype of the actual product. Because in front prototype, if we are taking a bowl of cup means we can design the prototype of the cup. In prototype of the cup also we can design how the design is okay or not. It's handy, because we are human. We are applying the design. From that, how it is going to behave. So there will be no paperwork, because in software itself you are going to design, and then you can share the data from with the other application. By using the SUDHAKAR, you can share the data to the other application also. And then shorter preparation time for drawing, because in manually we can drawing means there will be a mistake means you have to again do as a first itself. But in by using software, we can easily undo, we can easily add or delete or anything we can do easily, because of that we can some time saving will be occurred. Okay, and then manpower requirement also, because one design is okay for that one product, for several product, because we cannot use 4 or 5 members to do that, because we are going next we are going for the automation only. Automation the machine also, there is a manpower will be reduced. Okay, and then more efficient operation in drafting, because the design is perfectly okay means the machining operation will be come as a perfecting okay. The next one is the low wastage of drawing. There will be no wastage of drawing, because we can software, we can the data are available there. There will be no data wastage will be there. Okay, so next one is the revisions are possible. How many times we can repeatedly we can go through the design, and that we can easily. Next one is assisting in preparation in documentation. So if you are going for the documentation means you can go to the software. There will be a step-by-step procedure of what we have created. So from that we can easily prepare the documentation. I have done the first step here, second step here, third step here, fourth step here. We can easily documenting the what are the material we designed. Okay, so and then we can use the colors to be customize the product, because there will be several parts will be arranged with that. From that we can use the different colors for different parts. From there we can easily identify the what are the products. This part is this one, this part is this one. We can easily identify that. Okay. Next one is printing can be done on any scales. Okay. These are the printing on any scales means like any scale means there will be no limitations of size. We can get a large number of that, because we are going to create a part by part only. We are not designing the whole design in one process. For that we can use scalings will be not commendable. Next one is the preparation of assembly and sub-assembly drawing, because we can create several product parts in the one designing, and then we can schedule that these assembly parts. This is the secondary part, because first assembly is the major part, and then second assembly, sub-assembly is the screw, nuts and bolts, the second assembly problems. Okay, then we have a hydraulic and pneumatic circuit drawings with the symbols. By using diagrams, we can also design the hydraulics and pneumatic circuits, like anode, cathode, like anything. We can like valves, like solenoid valves, line through. So what are the electrical lines? We can easily draw with the symbols. So these are the introduction of CAD. So basically, by using the CAD, we can easily draw the diagram, what are the aspects we are thinking, and we can create the product creativity by analyzing the several techniques on previous designs. There will be a clarity will be there. So these are the introduction to. Thank you.